Good morning or afternoon, wherever you are. It's Matt Coleman. I'm the co-founder of Magnify World. We champion new technologies in emerging space and also AR and VR. And today we have a special guest, Lisa Rich, who's the Chief Operating Officer from the company XPLORE. Hi, Lisa, how are you?
Hi, Matt. Great to be here.
Yeah, thanks for joining us. Look, just starting out, you've got a very interesting topic today about space exploration in many areas of the world and how that affects humanity to business. Could you just tell us a little bit about your role in the company and exactly what XPLORE does?
Sure, I'm happy to. I'm founder of XPLORE and as well Hemisphere Ventures. And our journey began with Hemisphere when we developed a thesis for investing that involves frontier technology, an entire focus on what's happening in terms of the synergies between synthetic biology, robotics, drones, and the space sector. So as we think about Ray Kurzweil's book on the singularity, we know that capabilities are converging, and as we can develop technology that can scale, we have more power behind what we can do on a smaller scale at a lower cost, and that the ability to apply maybe software plus hardware, bringing in AI, ML, et cetera, compounds the outcomes we can achieve with any given problem. And so for Hemisphere, we had invested in a lot of companies. We have a portfolio of 200 companies, and we have a space portfolio of 18 companies. We're one of the more prolific investors in the space industry and have been involved in that sector since 2014. And we decided that as founders, my business partner and I that founded Hemisphere Ventures planned on our next venture being a space company. We weren't quite sure what that would mean. So we spent 6 years or so, 2014 until 2017 at least, deciding what it would take to build a space company and what would that strategy require to have something that would have legs.
If you're a budding entrepreneur, what are the sorts of technologies you're actually looking for? I know there's probably a vast range of opportunities in the space race, but is there something that you're focused on in particular at the moment? I know you did a press release yesterday, and I'd like you to explain what that means to the world, which is interesting.
Sure. Well, I think similar to with Hemisphere and our investing philosophy, we're always looking for the groundbreaking new ideas that allow for early revenue opportunities and accelerated growth. So there's a big vision, there's always a big vision, but there's a strategic mindset in how you're going to connect those dots to achieve that vision. For investors, the investment landscape, you're looking at 10-year timeframes where you would expect to have some sort of liquidity event. And so the companies that we work with are not thinking in the 3x, 5x range. They're thinking, what can we do to create a whole new category, perhaps, that hasn't existed before? So these are really hard problems that founders need to solve. So while there are advantages to investing in maybe the version 2.0 companies that have gone into a marketplace after the version 1.0 companies have attempted something, I think that we're finding the people that can look forward in a strategic way to have that bigger mindset and what are they going to have an early outcome for us? So there's always the proof points that we need to see. And I don't know specifically, I can give some examples on how that might apply different companies. We work with so many, but I think there's a lot of creativity involved in understanding what those early revenue opportunities are. And it has to go beyond, if I can just say, the we're going to sell and license our IP strategy, which I think just is not something investors want to hear.
It is artificial intelligence quite prominent in the space race with the proposals that you see or have invested in. You mentioned that AI before. Can you give an example of how that could be used?
Sure. Well, so it's interesting that some investors think that we're at the point where we can buy data and invest in analytics companies and we've solved the space investment, like the space investment opportunity is that, but it's not there yet. So like a company we have with Hemisphere that's called Hive Mapper is stitching together imagery from multiple sources at multiple angles at multiple altitudes to stitch together a cohesive image all in one. And their sources are varied sources. So you could get, mapping that's on one solid plane, and that's pretty valuable. And that requires a lot of AI and programming, et cetera, to achieve that goal. So that's a company that's kind of ahead of the game in that arena.
So when you say mapping, that's mapping the surfaces of the planets and...
Right. So agricultural companies want to have data to understand damaged areas of their crops, or logistics companies want to understand the traffic jams or, hindrance points, or how they can get from point A to point B faster for last mile delivery. And I think all of those problems are going to continue, and access to those answers is farther down the road, typically, because we still need the source information that's valuable, and the source information comes from next generation hardware, higher resolution imagery, higher cadence imagery, the ability to have that derivation between the original imagery, like if it's temporal, if you're doing Earth observation, that type of thing.
And with the recent liftoff with Elon Musk's project, that's given the industry a bit of a boost in terms of profile in the media. Hopefully that will encourage new entrepreneurs to focus on this sector of the market. From what I can see, it's great for the industry. The other interesting company that I wanted to mention, I don't know if you've heard of a company called Tesla Suit. They have a biometric suit that for potentially training astronauts and things like that, and could be in sport as well, actually, or any other things. But there's so many unique innovations that I see across. I'd love to share that with you at some stage.
Yeah, that's interesting. I've had the privilege of putting on a decommissioned glove from the spacesuits that they fly to the ISS that the astronauts wear. And the glove itself is classified as a life support device.
Right.
And when you look at it and you understand the architecture behind it, it's like 14 different layers of unique materials, and different clamps and different security devices to ensure there's no permeability, there's no air getting out, that type of thing. So these are very, very complex devices, and when you're talking about human life support, that's a whole other ballgame. We tend to focus on the robotic angle of space because it's lower risk and more early opportunities for achievement. The human angle, certainly those problems are being worked on. And a friend of ours, Ted Southern, who designed space suits at, what is his, Final Frontiers is the name of his company. That will be a need longer term. And the biometric ability that you're talking about is now, I think, trickling down the qualities of a spacesuit for use with athletes and that type of thing, which I think performance wear is an interesting application.
Yeah, good. And tell us about the press release that just
Oh,
came out
yes.
today.
Thank you. Yeah, because we were talking about the human element, and while we at XPLORE are focused on robotic exploration, that robotic exploration is informing and helping improve the quality of life on Earth, ultimately, with the knowledge we bring back from space. So our press release is about an award that we won with NOAA, the National Oceanic and Atmospheric Administration, where we will be studying our capabilities with our spacecraft here, the Xcraft, which we are going to take to the Earth-Sun L1 Lagrange point to provide solar weather observatories for advanced weather monitoring, so we are more knowledgeable about solar events. And solar events can be quite catastrophic. If you, for fun, want to look up the Carrington event that occurred in, I think it was 1859, 1869. At that time, across the Earth, the only kind of big networked capability we had was telecommunications, and it knocked out that entire capability across the Earth. So if you think about the electrical grid today and the infrastructure and all of our connected devices, solar flares, when we don't have enough warning and we don't maybe disconnect the grids, could sustain tremendous damage. Lloyd's of London estimated that an event that we narrowly missed in 2012, which was similar to the Carrington event, would have caused $2.6 trillion in damage and knocked out our power grids and had us outages that could have lasted 4 to 10 months. So imagine the instability. I mean, we think the pandemic is bad. The catastrophic effect of not being able to run water in your household, have the lights on, be able to communicate on a cell phone device, that is a very real danger, and NOAA understands this, and they have capability to monitor from L1 currently, but this is a next-gen capability so that we have more precise warnings and a faster ability to prepare for the damage that solar flares can cause when they hit the Earth.
How much in advance can you actually pick a solar flare up? And can you just explain to the listeners what the L1 position is and things like that?
Well, L1 is as a position between the Earth and the Sun that allows us to have to hover. It's basically between that gravitational point between where the gravitational points allow it to hover between the Earth and the Sun, where it's not pulled in either direction. Yeah. So it hovers, and it can observe and stay in that position to have full observation capability 24/7, because the sun is in, the Earth is in view and the sun is in view, or I think I have that backwards. But as we gather the data, we can get up to 24 hours notice. This has to be, these measurements have to be taken, and obviously we have to prove out the concept of how much sooner can we learn about the oncoming event of solar impacts. And as I was mentioning to you, a really fun articles to read, fun but scary articles to understand more about the impacts that this can have, other than reading about the Carrington event, is in 2017, Discovery magazine covered an anomaly of mines that had been put on the seafloor during the Vietnam War. And these mines were exploding, and they didn't understand why in the world were they having explosions in the ocean. And it was because the solar flares reached the Earth and hit these areas and caused these explosions. Can you imagine?
Can't
There's
imagine.
so much that we don't understand about. We think about Earth weather because that's our world, but the farther out we can gather data from space, L1 being 1,000,000 miles from the Earth, 3 times the distance farther than the moon.
Hmm.
This is really useful information to know about these particles that can be extraordinarily damaging to our infrastructure.
That's yeah, very interesting. Congratulations on getting that out yesterday. And look,
Thank
I
you.
wanted to talk about what's behind you, the craft, the Xcraft. Tell us about the history and the orbit of that, and the launch, and where it is today. I'm sure.
Sure. Yeah, as we looked to build a space company and looked at what our strategy would be, we wanted to see what the gaps were in the existing marketplace. Right now, space exists in LEO. The activity is in low Earth orbit, and it's focused on communication and observation. And that's the marketplace today. And that marketplace evolved out of the Landsat government satellites that then went commercial. So as we're thinking in the future about commercialization, we said, why can't we take the tools and techniques that have been proven out in LEO and apply them beyond Earth orbit to go deeper into space and accelerate our knowledge of space science. And in order to do that, we need to build a spacecraft capable of going to these extreme environments. So today's commercial companies that are focused on LEO are able to, if you go to the ISS, you're going 254 miles above the Earth. If you're going a little farther out, maybe these satellites are maybe, we always talk in miles because we're Americans here, but let's say it's 400 miles to 600 miles maximum that you might be traveling with your satellite. But for deep space, we said, what if we build a spacecraft capable, the same spacecraft that could go into Earth orbit, but that could transition out farther into space into these very, very extreme environments, up to 300 million miles into our solar system. So it's orders of magnitude, the capability is orders of magnitude greater than what's been produced today. And it's so exciting because that's a whole new marketplace that we seek to create. We are seeking to be the standard bearer for the industry to have a modular, repeatable spacecraft. By being repeatable, we would have efficiencies automatically built into our system to be able to manufacture this really unique spacecraft, which can provide services equal to or and better than, tremendously better than what's been done previously for much larger budgets. So budgets of 200, 500 million, $1 billion. In the past, those are highly specific instruments that government agencies have designed to answer the mysteries of our universe, questions about that answer the decadals, and all of that valuable science will continue. We're not certainly in that. That's not our market. That marketplace will continue as governments sending very unique, hyper-specific instruments into space. But what we're doing is we're sending a spacecraft into space and allowing commercial companies, national space agencies, sovereign space agencies, civilian space agencies, universities, NGOs to come with us on our mission. So it's not, it's a multi-mission capability. And what's really exciting about that is that customers that they don't need $1 billion to have a mission. They don't need to have a one-off opportunity where all of their eggs are in one basket and they're flying this flagship mission. They can partner with us to send smaller instruments to be part of a mission, and that lower cost enables a programmatic capability. So for example, the UAE is sending their HOPE mission, which is for $500 million, the HOPE mission to Mars. Well, with a budget like that, they could have many instruments flying with XPLORE.
And what's the HOPE mission? Can you give us a bit more background on that?
Well, the UAE, they sent their first astronauts to the ISS last year. They're working on studies of Mars civilizations and, really thinking through that next opportunity of habitation on Mars. So the HOPE mission is about a mission to Mars. I don't have all the details on it. I know it's a large budget, and I know that they have a great program behind it.
I mean, Mars obviously is, being talked about on or living on other planets. I mean, I know we're talking about way in the future here, but I mean, when do you see people doing that? Just changing the subject.
Right. Because it's interesting. We're coming up with the human versus robotic question again. Yeah. And for us, for XPLORE, what we're seeking to do is enable that future human exploration by enabling the science that needs to happen now to inform us of the safety factors and the safe environments that we need to have a human exploration. So for example, if you're going to land on the moon, land on Mars, you need granular data of the surface to have a safe landing site. NASA has just awarded 3 companies the human landers for the moon. So Dianetics, Blue Origin, SpaceX, I believe, was the third, where it's together $1 billion that they've invested in a human lander for the moon. Well, we have information about the moon from the rovers that is more granular, so we can have knowledge of where those safe landing zones are. But once we get there, if we want it to be a habitable environment, we need it to be, we need to know where the water ice is. We need to have ideas on how we're going to process that water, turn it into fuel, turn it into even perhaps potable water, if that's possible, to survive in these environments. We also need to know where the habitats can be, the natural habitats. So on the Earth, we have caves, we have lava tubes that, are safe environments. And so similarly, we would expect to be looking for that on other planets. And so we need, kind of going back to the mapping question, is we need a granular level map in addition to this environmental data about the climate, the temperatures, the winds, the gases. All of those are kind of extraordinary data sets that are needed to understand how humans can survive in these environments. It's kind of interesting to think about the ISS, as I mentioned, which is 254 miles from Earth. We have done experiments on the ISS. There have been some biological experiments that have been done. One that I had learned about recently was using nematodes to understand the effects of radiation, and also they mimic our digestive tract. So how do we learn how humans would respond in these environments that we weren't born to live in, right? So that's the ISS. That's 254 miles away, but to my knowledge, we have not sent extraordinary experience beyond the ISS to even understand how humans would survive in a Martian habitat.
Yeah.
Unless they're in the spacecraft and it's pressurized and there's, all of the simulated human environment that we need. We have to consider the external factors that because it's all a domino effect up there, right?
Yeah. Yeah. No, that's right. With coming back to the Xcraft, I mean, if you're a university listening in, what would a partnership look like? Would they, yeah, can you just talk through that? How
Yeah,
they?
thank you for the question. We are currently looking for more principal investigators that are looking for missions that are beyond Earth orbit to the moon, in particular as a first mission, because what's unique about our capability of having a multi-mission spacecraft is that when you're on your way to the moon, you can have multiple instruments from multiple customers turning on and off at different times. So imagine if you're studying heliophysics and you want to get information from the sun on your way to the moon, or you want to get data mid-flight at different altitudes, then even planetary scientists certainly can get that data on the way to a farther off destination. So it's actually not so different from the way astronomers work today, for example, where they all vie for telescope time. There's a big calendar and they have to say exactly what time they want to perform observations. And obviously they're all using the same instrument. It's a giant telescope and an observatory.
Yeah.
But each scientist understands the parameters of what they're specifically studying and what details they need, so they know the optimal time that they want to get. And that's all shared currently, like shared telescope time. So we're kind of borrowing from that model.
That's great.
Yeah.
And look, I know you told me about it from a personal or from a consumer point of view here. You've got a website that enables you to send something to space.
Oh, thank you for that.
Well,
Yes, we just
I'd love to hear about
launched
that.
our public facing website, which is Explore Space. I don't know if I can put it in the chat, but I'll put it in the chat. It's
Yeah, I can put
Explore with an X,
yeah.
explorespace.com. And we are inviting citizens around the world to submit their name, which will be saved in our secure storage drive. And we will take your name to the moon with us for free. And what's exciting about that is not obviously just the fact that you can do it, is that this opens up the opportunities for other engagement with customers that want to send personal items to space, photographs. It really is about the idea of expanding your human footprint, what you can share with the universe, literally. And also it's unique in that missions to space aren't often long duration missions, but orbital missions can be long duration. So there's a marketplace, and this just kind of brings up another reason people go to space and the significance that they subscribe to it. There are companies that we have a relationship with, Celestis, which is, I think we mentioned on our website, or we've mentioned in our press releases. And Celestis is sending memorials in the form of ashes to space. So they are cremains. And on our first mission, we will be, I believe we're sending a Majel Roddenberry, who is Gene Roddenberry's wife, Gene Roddenberry, the father of Star Trek, and she'll come with us on our flight.
Wow.
And so the idea of having a loved one orbiting eternally in the universe, I think, is an extraordinary concept of, truly this idea of going to the heavens is achievable in this day and age. I think and it's not the first time it's been done. I mean, other famous people have been had their remains sent to space, and in fact, Jean's remains were sent, and so this is now her joining him.
That's a great story, that's for sure. And is there a deadline for applications?
No, this is open because we have our missions targeted in 2022, so there's time to participate. I think the sooner people do it, the more exciting it will be, because then they'll have a relationship with us as we ramp up the further opportunities they can have to engage with us, if there are personal objects they want to send and things that wouldn't be for free, but people understand the significance of space. And in the past, we know there's been kind of a proof point for the popularity of this. NASA's, I believe, Mars 2020 mission, they offered the opportunity to send your name to space and gathered 11 million names. So now we have our goal marker. That's our goal post. We'd love to supersede that and have even more people come to space with us, because we recognize that the mission to space, while it's going to service the needs of our customers that will have instruments that will be gathering their needed information in space, there's a human connectivity that also happens and an impact with everything we do that inspires people on Earth. And so XPLORE is, separately from our, obviously this is a for-profit business, we are giving citizenry the opportunity to be involved for free. And then we want to partner with more non-for-profits that want to promote STEM education. They want to promote the technological advancements and careers. And we can be a part of that too, with the influence that happens by inspiring people with our first missions to the moon.
Well, look, what a great conversation we've had. It's amazing, Lisa, what your company's doing in this space, and
thank you.
Promoting all these new technologies and really giving us, the world, an insight into the future on, what's going to happen, if you can live out there or not, I guess.
Yeah, I think that from a timing perspective, a lot of space companies exist that are doing kind of components. They're working on components. They're working on improving smaller spacecraft for Earth orbit. All of these are valuable and add to the value chain. And then you have companies that are looking maybe farther out, that are a little more sci-fi right now. So people that are looking to invest in space need to think about those timelines of, what can we achieve in a 10-year horizon. And so that's, I think, the bigger challenge with space companies is understanding what that horizon might be, and really investing in the companies that are making those early proof points happen.
And so just to finish up, so the couple of websites, we've got xplore.com, okay, with the X there, and can you just mention the other websites again?
So I have XPLORE Space. I posted in the chat, xplore.com. If people are interested in understanding Hemisphere, and I think we have most of our space investments listed under the space section, but it's hemisphere.com. We have, as I mentioned, a portfolio of 200 companies and now 18 in the space sector. Some of those companies are stealth and we actually can't post them, but we're heavily involved in the industry and appreciate attracting even more experts and people that are interested in the future of the industry and that want to invest in it and support it in other ways. We're always welcoming those conversations.
Fantastic. Well, Lisa, thanks very much for your time today. I'm sure you'll get a lot of people signing up to send their name in space.
Please sign up, send your name to space. It's a fun thing to do, and you can tell everyone in a cocktail party what you just did. It's kind of fun. Tell your kids, tell the kids. They can go to space too.
Okay, thank you very much, and
Sure.
we'll see you next time.
All right, thank you, Matt. Have a great day.
Thanks, Cynthia.
Okay, bye-bye.